So now that you have learned that the study of economics is all about individual choice, we defined economics in the first module as the social science concerned with the efficient use of limited or scarce resources to achieve maximum satisfaction of human economic wants. So we know now that economics is the study of scarcity and choice, and that every economic issue involves, at its most basic level, individual choice. Decisions by individuals about what to do and what not to do. In fact, you might say that it isn't economics if it isn't about choice. And we learned that there are different types of economic systems that are involved in helping us make those choices. The two dominant economic systems in the world today are market economies and command economies. Market economies are the most prolific type of economic system in the world today because of the incentives that they provide to produce the goods and services that people want. Well, now, as we advance our study of economics in this next module, and you may have noticed that this is Module 3, not Module 2. Module 2 in your book focuses on the study of macroeconomics, which is not the subject of this course, so we skip Module 2. But as we go into Module 3 now, we are going to be looking at our first model. Now, the reason that's important is because we will be dealing with lots of different models in economics. Economists are social scientists, and they study the world as natural scientists do. But economists are studying human behavior, and human behavior is infinitely complex. And when we want to create an experimental situation, such as in a lab, we can't really do that with human beings because of ethical concerns. So economists, as social scientists, are forced to create models of the real world. And these models are simplified models of the real world. And when they create a model, what they do is they control for multiple variables and isolate one variable to see the impact that it may have on another variable, to help us understand the choices and the behaviors of human beings. So in this course, we are going to be looking at many different types of models to help us understand human behavior in the world of economics. In this module, we introduced the first model. And the first model is called the production possibilities curve model. So let's see what this model is all about. In this model, or module I should say, we are going to be learning several different things. First of all, we're going to look at the importance of trade-offs in economic analysis. We're also going to look and see when the production possibilities curve model tells us about things like efficiency, opportunity cost, and economic growth. And from there, we'll look at the two sources of economic growth in a society, which would be increasing the availability of resources and improvements in technology. So let's focus on trade-offs to begin with and how they relate to the production possibilities curve. Now, as I said, we are looking at our first model, and all models have simplifying assumptions. All models assume the available supply of resources is fixed in quantity and quality at this point in time. Secondly, all models assume that technology is constant and does not change during analysis. Remember, in the previous slide, we said that two things that can lead to economic growth are an increase in available resources and a change in technology. Well, when we look at models, we assume that those things remain constant and do not change as we look at the model. We also simplify our assumptions of the complex world in another way. We assume that the economy produces only two types of products. Now that's obviously an unrealistic assumption because in the United States or any other country, most countries produce far more than just two types of goods and services. But remember, a model is a simplified analysis of a complicated world. And so keep all of those simplifying assumptions in mind every time we look at a model. That the available supply of resources is fixed in quantity and quality, technology is constant, during analysis, and the economy produces only 2 types of products. Now, when we talk about trade-offs, we say that someone makes a trade-off when they give up something to get something else. And remember, we said economics is all about choices, it's all about opportunity costs, and that means when you choose to use your time or your limited resources or your money in one way, you lose the opportunity to use it for something else that you want. And that is an opportunity lost, or what we call an opportunity cost. And so that means we are making a trade-off. We are giving something up to get more of something else that we want. And so because of that, we can create a model called the Production Possibility Frontier, or PPF. And the Production Possibility Frontier is a model or an illustrated way of looking at the trade-offs facing an economy that would produce only 2 goods. Remember, one of our simplifying assumptions. And this model shows the maximum quantity of one good that can be produced for any given production of the other good. That's why we call it the Production Possibilities Frontier, because it shows us what it is possible for a society to produce with its limited or scarce resources. So let's look at an example of this. Let's assume that we have a country that can only produce 2 goods. They can only produce pizza or bulldozers. And so here we have data in a table that will help us draw a production possibilities curve. This table shows us the maximum quantity of pizza or bulldozers that a society could produce if it used all of its resources to produce either good. So if a society used all of its land, labor, and capital to produce pizza, the maximum amount of pizza it could produce would be 200 slices of pizza, or 200 pizzas. But that would leave it no resources left to produce any bulldozers. On the other hand, if it used all of its limited resources to produce only bulldozers, it could produce 100 bulldozers, but no pizza. Now, what if it wanted to produce a combination of pizza and bulldozers? Well, this shows that if we wanted to produce 160 pizzas, we would have enough resources left to produce 20 bulldozers. If we were wanting more bulldozers, let's say 40 bulldozers, then we could only produce 120 pizzas. So it shows us all of the available combinations of pizza and bulldozers that we could produce by putting our scarce resources into the production of either good. And from this, we can produce a production possibility frontier, or what's called a production possibility curve. And it's a graphical representation of the production possibilities model. And so what we do is we create our 2 axes, and on the y-axis we graph the number of pizzas that we can produce, and on the x-axis we graph the number of bulldozers that we can produce. And so you can see that at one end of the graph we could produce 200 pizzas, but if you get on to the x-axis you see that we produce no bulldozers. If we produce 100 bulldozers, we can produce no pizzas. But as we move along the curve, any point along the curve represents a combination of pizzas and bulldozers that we can produce. Now, there are several points along the curve that we should be able to identify. You'll notice there is a point on the curve that is labeled E. And at that point, we are producing 160 pizzas and 20 bulldozers. Any point that is on the curve, not just this point that we've labeled, but any point that is on the curve, is called an efficient point for this society. Why is it called efficient? Because it means that we are using all of our scarce resources to produce pizza and bulldozers. We have no resources left over with which to produce more pizza or more bulldozers. So points on the curve represent maximum possible combinations of pizza and bulldozers given our limited and available resources and current technology. So at point E, which could be any point on the curve, given the decision to produce 20 bulldozers, the most pizzas that could be made are 160. Now notice there are points that are inside the curve. Points inside the curve represent underemployment or idle resources. So at point I, if 20 bulldozers are being made, we are only making 80 pizzas rather than 160. In other words, we have resources left over, land, labor, and capital left over that's not being used. And if we used it, we could produce both more pizzas and more bulldozers. So at point I, which would be any point inside of the curve, we are not at our full productive potential, so we are said to be inefficient in our production if we are producing a combination or quantity at any point inside the curve. Points outside the curve are what we call unattainable. They represent combinations of pizza and bulldozers that we can't produce. For example, if we look at point U, it looks like slightly more than 200 pizzas and 100 bulldozers. We don't have enough land, labor, and capital in our society to produce that much pizza and that much bulldozers. So we call that unattainable. We don't have the resources or technology to produce at point U. And point U would be any point outside the production possibilities frontier. So any point on the curve is efficient, using all of our resources. Any point inside the curve is inefficient, representing underemployment of resources. And any point outside the curve is unattainable, meaning we can't produce at that point. So all points along the curve are what we call efficient in production. Now, when we say that we are efficient in production, or productively efficient, it means that we are putting all of our available resources into the production of these two goods, pizza and bulldozers. Therefore, we cannot increase pizza production without giving up some bulldozer production, and vice versa. We can't increase bulldozer production without giving up some pizza production if we are at any point on the curve. It is also efficient in allocation. When we say that we are efficient in allocation, it refers to the point that this society wants above all others. In other words, the combination of pizza and bulldozers that society actually wants us to produce. That's allocative efficiency. We could produce any combination, but there's a combination the society would desire. So if society wishes to have more bulldozers than pizza, then a point like E would be efficient in production, but it would not be efficient in allocation. Here we see another example of this with a society producing coconuts and fish. You can see that points A and B are both efficient points on this curve because they represent quantities of coconuts and fish that a society can produce using all of its resources. If a society is producing at point B and wants to produce at point A, then it has to give up fish to get more coconuts. If it's producing at A and wants to produce at B, then it has to give up coconuts to get more fish. If it's producing at point C, then it can produce more coconuts and more fish without giving up any of either, because that is inefficient. So any point inside that is represented by the blue shaded area is inefficient. Point D, representing a point outside the curve, producing 30 coconuts and 40 fish, is not possible. We don't have enough resources to be able to do that. So point C, feasible, but not efficient. Point D, not feasible. Any point on the curve, feasible and efficient in production. So, this is what we've learned about efficiency. The production possibilities curve illustrates efficiency. We say an economy is efficient if there is no way to make anyone better off without making at least one person worse off. In other words, if one person wants more coconuts, then the person that wants fish is going to lose out because there will be less fish produced. There are two different types of efficiency, as we said. There is productive efficiency, and we say an economy is efficient in production if it produces at any point on its production possibilities frontier, because it is using all of its available resources to produce the maximum quantity of goods and services that it can. But an economy can also be efficient in allocation, allocative efficiency, if it allocates its resources that consumers are as well off as possible, meaning the point that they are producing at on the curve represents the point and combination of goods and services that society actually wants. So there are two different types of efficiency. So the production possibilities frontier is a reminder that the true cost of any good is everything, not just money, but everything in addition to money that must be given up to get that good. And that is what we define as the opportunity cost of a choice. So, what is the opportunity cost or trade-off between pizza and bulldozers? Well, it's 2 to 1. To gain 20 additional bulldozers, we have to give up 40 pizzas. If we reduce that to lowest terms, that means for every bulldozer we want to gain, we give up 2 pizzas. Now, if we go the other way, if we want to gain 40 pizzas, we have to give up 20 bulldozers. Reducing that to lowest terms, that means for every pizza we want, we give up 1/2 of a bulldozer. So, the opportunity cost of one bulldozer is 2 pizzas. We give up 2 pizzas for every bulldozer we want, and the opportunity cost of a pizza is 1/2 of a bulldozer, meaning for every pizza we want, we have to give up 1/2 a bulldozer. Now, here's a tip for you to remember. The opportunity cost of a good that is graphed on the x-axis is always the slope of the production possibilities curve. The opportunity cost of the good on the y-axis is always the inverse of the slope of the PPC. So it doesn't matter what the initial point on the PPC is, what point we start at. The opportunity cost of one more pizza or bulldozer is always the same. So if you notice the slope of the opportunity cost, it is constant. So what does this tell you about the substitutability of the resources used to produce pizza and bulldozers? It tells you they must be perfectly substitutable. Now, is that reasonable? Think about this. If we want more bulldozers, and if we were controlling the economy, what would we need to do? We would need to move some pizza makers and capital and natural resources making pizza into bulldozer production. Now, have you ever had a bad pizza or a great pizza? Sure, some pizzas are better than other pizzas. Is it safe to say that not all pizzas are created equal? Well, then is it also safe to say that not all pizza makers, the labor used to make pizza, are created equal? No, some people are better at making pizza than other people. Are some pro athletes better than others? Yes. Are some acres of land more fertile for growing food than others? Yes. Are all laptop computers equal, or are some faster than others? Again, the answer is yes. The point here is that resources are not created equal. So, can you agree that some units of labor are better pizza makers than others? If that's the case, then let's redraw the production possibilities curve differently than we did before. Now, in this slide, you see that we are redrawing the production possibilities curve with a concave shape. And we don't need numbers. Okay? This is something that economists call the law of increasing opportunity costs, and it is so true that they refer to it as a law. Now, what does that mean to say the law of increasing opportunity cost? Well, in the previous example, because the slope of the curve was constant, that represented more of an unrealistic example of constant opportunity cost. But in the real world, the opportunity cost of making more of one good rather than the other usually involves the law of increasing opportunity cost. So what does that mean? It means that, number one, the amount of other products that must be foregone to obtain more of any given product is called the opportunity cost. The more of a product we produce, the greater its marginal or additional opportunity cost. And 3, the slope of the production possibilities curve becomes steeper going left to right, which demonstrates increasing opportunity cost rather than constant opportunity cost. And this makes the curve appear bowed out or concave from the origin. Well, why is that? What explains that? Why is it more true that we have a concave production possibilities curve with increasing opportunity costs? Well, there are a couple of reasons for this. One is that economic resources are not completely adaptable to alternative uses. In other words, the resources that we use, the land, labor, and capital we use to make bulldozers, are not perfectly suited to make pizza, and vice versa. The resources we use to make pizza are not perfectly suitable to be switched into making bulldozers. So this leads to the second explanation for the law of increasing opportunity cost, and that is, if we want increasing amounts of bulldozers, resources that are not particularly well suited for that purpose have to be used. Workers that are used to producing pizza in a restaurant may not do as well as heavy equipment builders. A pizza oven is a piece of capital equipment that is not very adaptable to building bulldozers. So, as you look at this graph here, as we move from point A to point B, you can see there is a large gain in bulldozers, but there is a very small loss in pizza production. Why? Well, focus on the labor resource, pizza makers and people that make bulldozers in a factory. That's easiest to identify with. So as we move from point A to B, imagine you have lined up the labor from the worst pizza maker to the best, Papa John himself. Who do you release from the kitchen to go to the bulldozer factory first? The worst pizza maker. Since there are only 2 skills in this economy, the worst pizza maker should be the best manufacturing worker. So you get a big gain in bulldozers coming at a small opportunity cost in pizzas. But as we move further along the curve and produce more and more bulldozers, you keep releasing the next best pizza maker to go work in the factory. Finally, you get to the end of the line and you are left with Papa John, the best pizza maker in all the land. So when we move from point C to D, when you send Papa John to the factory to make bulldozers, you gain very little bulldozer production. After all, he is likely the worst manufacturing worker left. Otherwise, you would have sent him to the factory a long time ago. Since he's the best pizza maker, you lose a lot of pizzas. But he doesn't give you many bulldozers in return. A small gain in bulldozers now comes at a very high opportunity cost in pizzas. And that is an example, an explanation of the law of increasing opportunity cost. The same thing is true if we look at our example of coconuts and fish. Here, we see at point A that when we produce the first 20 fish, we go from 0 to 20, that it requires giving up 5 coconuts. But as we move from point A to the point that gives us 20 additional fish, that requires giving up 25 more coconuts. So the first 20 fish cost us only 5 coconuts, but the second 20 fish cost us 25 more coconuts, 5 times as many as the first 20. So we've given up more coconuts for the second 20 than we did for the first 20. That is increasing opportunity cost. Now, all of this leads to economic growth. Societies desire economic growth because when societies grow economically, then they are producing more goods and services than they did before, and that means there are more goods and services to go around for all of their people. And living standards can rise, and people can live a higher quality material life. So societies desire economic growth, but how do they achieve it? Well, economic growth means an expansion of the economy's production possibilities. In other words, the production possibilities curve shifts outward and allows the economy to produce more of both goods and services than it could before. The economy then can produce more of everything. That's why we call it economic growth. So there are two general sources of economic growth. The two main ways that a society achieves economic growth is to increase its available resources. In other words, it discovers more raw materials, natural resources, which is what we refer to as land, or the population grows and they get more labor or more productive labor, or the society produces more capital goods that can be put into production. An increase in any of those resources allows a society to produce more. And those are the resources that are used in the production of goods and services, or what we call the factors of production: land, labor, and capital. The second source of economic growth is that a society improves its technology. There's progress made in technology. Technological improvements allow a society to produce more goods and services out of the same quantity of available resources, to get more out of them. And therefore, it produces more and is more efficient. So, this is what it might look like, okay, with coconuts and fish. When we see our original production possibilities curve, we are at an efficient point if we produce 25 coconuts and 20 fish. But what happens if economic growth occurs? This is illustrated graphically by shifting the production possibilities curve outward. Now remember, before this point in time, a point like point E would have been impossible on the old curve. It would have been unattainable. Producing 30 coconuts and 25 fish would have been impossible. But with economic growth, now that represents a point on the new curve. The entire curve is shifted outward, meaning that we have the resources or the technology now to produce more coconuts and more fish. And so we have all new combinations that can be produced. So how could this happen again? Well, this could happen if the factors of production expand in either quantity or quality. A bigger workforce or a more educated or skilled workforce is one example. So improving the factors of production in either quantity or quality will lead to economic growth. It can also happen, as we said, when technological advances are occurring. Technology always advances, and we don't forget our technology, so we don't usually go backwards in terms of technology. So here's an example of economic growth that favors one product over another. Let's say that a simple economy produces corn and cars. Let's assume that an economy produces corn and cars, and let's go back to the previous slide. I advanced one a little bit too soon. The initial concave curve would be a PPC, but what if we develop better fertilizers for our crops? Would better fertilizer enhance car production? No. So the PPC would shift outward in the corn direction, but it would leave the maximum number of cars unchanged. So sometimes it's important to remember that we could have an improvement in technology or an increase in the quantity or quality of resources that could lead to an increase in the production of one good, but not necessarily another good. And if that happens, the entire curve would not shift outward. It would shift out at one point on one axis, but not shift out on the other axis. So as we wrap up this module, here are a couple of tips to keep in mind for the AP exam. And as in each of the video modules that I produce for you, I will be giving you tips that you should probably write down and copy in your notebook as tips and things to really focus on that will help you with the AP exam. And generally these tips are around things that typically give students trouble or that students tend to forget. So they're important to focus on and keep in mind to really help you understand the material and achieve the best results. So here's one tip. Be prepared to draw a correctly labeled production possibilities curve. Sometimes you have to do that on the exam. You have to draw a PPF from scratch. So you have to draw the y-axis, the x-axis. You always have to label your graphs accurately and completely. Graphs must always be labeled. You can earn points on the free response section of the AP exam for proper labels on your graphs, and if you omit them, then you don't get those points. So you always have to draw your graphs correctly, and you also have to label them fully and accurately. So get in the habit of doing that from the beginning of the course, because there are many graphs that you're going to have to learn in this course, and many times you have to draw them from scratch. And when you do, they have to be drawn fully, completely, and accurately and properly labeled. So be prepared to do that with the PPF, and be prepared to be able to interpret it, to use it to identify what the opportunity cost of a choice is, to be able to identify the efficient points, the inefficient points, and the unattainable points. Sometimes you are asked to identify those on the exam. Unemployment results in production at a point below the production possibilities curve. You should know that would represent an inefficient point. Most production possibilities curves that are shown to you are concave to the origin, as we saw in figure 3.2, and that's due to the specialization of resources that we talked about previously. A second tip to keep in mind is what the word opportunity cost actually means. It's often useful to think of it as the opportunity lost. In other words, when you make a choice, you lose the opportunity to make a different choice that you also might like to have. So it's what you're giving up, and it's not just money, it's everything you're giving up to make a choice. That's the opportunity cost of a decision. So it could be financial or non-financial, and it's the cost of a choice that you didn't make. So make sure you understand what the opportunity cost of a choice is and all that it involves. So here's a summary of what we've learned in this module. One important economic model, the first one that we're learning, is the production possibility frontier. The PPF illustrates for us these concepts: opportunity cost, efficiency, both allocative efficiency and productive efficiency, and economic growth. And there are two basic sources of economic growth: an increase in either the quantity or quality of the factors of production, land, labor, and capital, and an improvement in technology, which allows us to get more out of the available resources that we have. This concludes our look at Module 3, the Production Possibilities Curve Model.